Welcome to our natural logarithmic function lesson. So our natural logarithmic function is a special type of log function where your base is e. And e is just a special number, just like how pi is. And it's usually 2.7, 1, and then a bunch of other numbers after that. So we would usually write the natural logarithmic function as ln x. Equivalently, you could write it as log base e of x, but we don't really write that ever. So every time you see the natural logarithm function, it is going to be in the form of ln x. And because this is a special type of log function, it already satisfies any log function where that we always will pass through the point of 1, 0 on its graph. You have a vertical asymptote at x equals 0. Your domain is from 0 to infinity, and your range is from negative infinity to positive infinity. And if you take a look at the graph of y equals ln x, it just looks like any other log graph. Again, because this natural log graph is a type of log function, it will satisfy all your log laws. So this includes your product law, your quotient law, and you just need to put a division sign in there. That's a little typo. So that's your quotient law. And then lastly, your power law. Not only does the natural log function have these type of properties, but it also has a few more identities you need to remember. There's 4 of them. So ln e to the power of x is equal to x. In other words, if I were to change it to exponential form, it'd be my base is e, our exponent x, our answer is e to the x. Pretty self-explanatory. Of course, e to the x is equal to e to the x. For our second one, e to the power of ln x is equal to x. Again, pretty self-explanatory, because if I want to change this into logarithmic form, we're going to get our ln, our base is already e, our exponent is x, and then our answer is ln x. So we're just going to get ln x is equal to x. Again, it's the same sort of thing. For number 3, this comes from changing this into exponential form. So e to the power of 0 is equal to 1. And that makes sense because anything to the power of 0 is equal to 1. Again, if I want to change it to exponential form, our base is e, our exponent is 1, our answer is e. Of course, e to the power of 1 is e. So those are coming from, and you just need to remember these results and apply them to the following type of examples. So we want to express ln 3 equals x in exponential form. Our base is always going to be e. This is your answer, and this is your exponent. Very similar to your regular log form. So we're going to have e to the power of x is equal to 3, and that is ln 3 equals x in exponential form. Moving on to example 2, express e, x to the x minus 6 is equal to 19 in log form. Okay, so we have ln, our base is e already, our answer is 19, and our exponent is x minus 6. So again, this is your answer, this is your exponent. Example 3 is the laws of logarithms to expand ln 4th root of a plus b. So the first thing I'm going to do is change our 4th root into a power, and our power is going to be the quarter. And if you don't remember this rule, I can just write it on the side. You should have learned this back when you learned about radicals. So x is equal to, or the a root of x to the power b is going to be equal to b over a. So this is where your root is, and this is any exponent that could be attached to the inside of your root. Okay, then from here I'm going to use the power law by bringing down my quarter. And at this point, I'm done. I can't go any further. Do not try to expand the a plus b to ln a plus ln b, because that is not your product law at all. You cannot try to expand any further than this. Our next example, we're just going to change this a bit because, again, typo. It's hard to format this into Word sometimes. So we're going to combine 4 ln 3 plus 2 ln 2 plus ln e into a single logarithm. I'm going to use our power law here to bring any number in the front of our ln with the inside of our ln. So it'll be 3 to the power of 4 plus ln 2 to the power of 2. And ln e is equal to 1 as one of our properties, but because I'm trying to combine this into a single logarithm, I'm not going to change it to 1 because then I can't. So I'm just going to leave it as ln e. Now I'm going to use our product law here to combine them all together because we have a plus sign in between each term. So this becomes 2 to the power of 4 times 2 to the power of 2 times e. 3 to the power of 4 is 81. 2 to the power of 2 is 4. And then we're going to simplify the inside of our ln, which is 324. And that would be all we can do to combine into a single logarithm. For our next one, we're trying to solve for x. So e to the ln of 4 is equal to x. According to our rule from up here, which is number 2, e to the ln x is equal to x. That means our x is equal to 4. In other words, because e and ln are inverses of each other, we can just take them out. For number 6, we have ln e to the power 7x is equal to 343. I'm going to bring down the 7x using the power rule. And then we know that ln e is equal to 1 according to our properties from up here, which is property number 4. So we know this is 1. So 7x is equal to 343. Divide 7 on both sides, so x is equal to 49. For our next example, we want to solve for x. I'm going to isolate the e to the power of 1 minus 2x by subtracting 4 on both sides. And then I'm going to actually take the ln of both sides and then bring my exponent down. We know that ln e is 1, and 1 times 1 minus 2x is just 1 minus 2x. And then I'm going to rearrange and solve for x. Then I'm going to divide both sides by 2. And that's our final answer. Lastly, for question 8, just like our other log equations, I'm going to try to get ln x by itself. So that means I'm going to add ln x on both sides, and then add 2 on both sides. So we have 3 ln x plus ln x is equal to 1 plus 2, which is 3. Now I'm going to combine our ln x's, but I need to bring this 3 in first using our power rule. Now I'm going to use the product rule and simplify. And I'm going to change this into exponential form. So you have e to the power of 3 is equal to x to the power of 4. Because I'm solving for x, I'm going to take the 4th root of both sides. So we're left with e to the power of 3 over 4 as our final answer. Okay, again, from here to here, all I did was rearrange. Here to here, I use the power law. Here I use the product law. And then from there on, I just simplified. And that's it for this lesson. We got a taste of how to do each and every question using our natural logarithm. Just as a reminder, it's very important that you remember these 4 new identities related to the natural logarithm, because that's definitely going to help you to solve any natural logarithm questions in the future.